Hi everyone, this lesson is about Bernoulli distributions, which are a type of probability distribution. Now these ideas were first developed by Jacob Bernoulli, who I've put a little picture there that I stole from Wikipedia. He was a very famous Swiss mathematician. In fact, the Bernoulli family had many members who contributed to mathematics. Jacob's probably the most famous of the Bernoulli family. Now, the Bernoulli distribution, or a Bernoulli event, is an experiment, a probability experiment, where there are only two different outcomes. That's the most important defining factor. Now these outcomes are usually denoted as a success or a failure. Now, the words success and failure don't really mean what they normally mean. So, for example, a Bernoulli trial or a Bernoulli event could be tossing a coin, where you consider getting a head is the successful outcome and getting a tail is the failing outcome. On the other hand, a Bernoulli event could be when a new baby is born. You could consider that a little baby girl is a successful outcome and a little baby boy is a failure of an outcome. Now that's not to try and judge whether a baby boy is better than a baby girl or vice versa. It's just that we have two outcomes and they're usually designated in this way as a successful outcome or a failing outcome. You could say, I'm going to take a maths exam in third term, and if I pass the exam, that's a successful outcome. If I fail the exam, well, that's the opposite outcome. So it's got to be just two choices. We wouldn't be worried about, I'm taking an exam and I could get an A, a B, a C, a D, or an E. So we really do just split it down into two things. Now, the probability distribution, as we learnt from grade 11, a discrete event, we can describe the probability of these things in the following way. So it's a distribution where the probability is designated by the amount P or the amount Q. These numbers would be any allowable probabilities between 0 and 1, and we would say P is the value of X equals 1, and that's usually the one that we call a successful outcome. And if the value of X equals 0, so the probability was Q, that's the one that we call a failure. So there's really only the two choices. The probability, so X is the event, passing the exam. Usually the name of the event, capital X, is in terms of the successful outcome. So getting a head on tossing the coin, or rolling a die and getting a 6. So I either get a 6 or I don't get a 6. I don't care about what the other outcomes are. It's a 6 or it's a fail. So that's what the capital X represents, the event, and the little x is either 1 or 0 depending on whether you've got the favourable or the unfavourable outcome. Now, as we saw last year, we can represent a discrete event as a probability distribution. Now there's only two values for x, 0 and 1. In the event that it was a x of 0, then the value is q. In this event it's p. Now the other thing that I need to mention, of course, is that in probability, if there are only two possible outcomes, then the sum of p and q must equal 1. Now, what did we know last year if we recall our prior knowledge? Well, we know that the mean, or the expected value of our event, is the sum of x, the individual scores here, multiplied by the probability. So what do we find? Well, if x equals 0, we multiply by q, and then if x equals 1, we multiply by p. Clearly then, the expected value is p. Now I'll just go sideways a bit. So that's one important result. The mean or expected value is p. Let's just highlight that. Now the other thing that we'll remember from discrete events back in grade 11 is the variance. So just to remind everybody, I'm sure you do remember this, the variance was the value of x squared multiplied by the probability. subtract the mean squared. So sum of x squareds. Well, let's have a look. If x could be 0, so we'd have 0 squared multiplied by q. Obviously that's a 0. And we could have 1 squared multiplied by p. Now we subtract the mean. But remember, the mean was p. So that's p squared. So 0 times that is nothing. We end up with p subtract p squared, which I will factor p and have 1 minus p. And sometimes you'll see this written, and more commonly I think 1 minus p from back here. 1 minus p is q. So the variance is literally the probability of success multiplied by the probability of failure. That's quite a simple outcome. And then it follows directly that the standard deviation is the square root of the variance. That's the definition of standard deviation. So those ones there in red are the most important rules, that the expected value equals p, the probability of success, and the variance equals p times q, which is the probability of success multiplied by the probability of the failing outcome. Now, let's have a little bit of a couple of examples here. So, first example, determine whether these individual situations would be resulting in one of these Bernoulli distributions. Are these events, now the most important defining outcome was the characteristic, 2 outcomes. So you take a driving test and you record whether you pass the test. Well, passing is one outcome, failing is the other outcome. Yes, this is a Bernoulli event. Tossing a coin 5 times and recording the number of heads. Well, you could get 0 heads, or 1 head, or 2 heads, or 3 heads. Well, no, there are more than 2 possible outcomes. Rolling a 4-sided die, so that must be a tetrahedral shaped die, and recording the number that occurs. Well, if it's tetrahedral, so there are 3 of these little triangular surfaces, there are 4 different numbers, there are 4 outcomes. This is not a Bernoulli event. And drawing a card from a deck, recording whether or not it is a heart. So when you draw the card, it is either a heart, success, or it's not a heart, fail. That is 2 outcomes, that's a Bernoulli event. I mean, really, what could be simpler? 2 outcomes or not? Now, here's another example where we might do some calculations. A drug has been developed for the treatment of skin cancer. Hooray. The drug is found to be effective in 81% of cases. Now they define for us the effectiveness of the drug is X. So here we go. The probability of success, so X is effectiveness, 81%. So the probability of success that the drug is effective, 0.81. Q then, let's just work that out straight away. 1 minus 0.81, so this would be 0.19. Remember, it's only success or failure they must add to equal 1. Construct a probability distribution. All right then, so X could equal 0 or 1. The probability that the event equals, excuse me, X, well, in the event that X equals 0, it's a fail. This is 0.19. Otherwise, it's 0.81. There is your probability distribution for this event. Now that was part A. Part B, find the expected value of X. Well, that's just equal to P. We already know that that is 0.81. Done. Simple as could be. Part C, find the standard deviation. All right then, so the first thing I know, if I want the standard deviation of X, I suppose I should write that this is the square root of the variance. Remember, the variance was P multiplied by Q. P is 0.81, Q Q is 0.19. Probably would have helped if I'd worked that out earlier, wouldn't it? Well, just bear with me for a minute. Now, they did say 4 decimal places, which seems a little excessive to me, but hey, who am I to argue? So I've got 0.3923. That's the standard deviation of this distribution. So the mean value is 0.81, the standard deviation. There you have it. That's a very brief introduction to the concept of a Bernoulli distribution, a probability experiment with just 2 outcomes. That's all for now. See you next time.